70-740 Lesson 9, Configuring Hyper-V Storage. This is our third lesson that covers Hyper-V and our virtualization. In the first lesson, if you remember, we covered how we go about installing the Hyper-V role. Our previous lesson, we looked at how do we go about configuring a Hyper-V virtual machine. In this lesson, we're going to take a deeper look into how Hyper-V storage is configured. So we'll be looking at the difference between a pass-through disk, a differencing disk, a dynamically expanding disk. How do we configure and add those virtual disks to virtual machines? What's the difference between a VHD and a VHDX? Looking at quality of service, many different areas. This is here again. This is a fairly short lesson. It's only about a little over 12 pages maybe. So let's get into it. After we create a virtual machine in Windows Server Hyper-V, we do what we call emulate. We emulate all those components that you would normally see in a physical computer. We have a virtual processor, we have virtual memory, we have a virtualized BIOS or UEFI firmware, our our hard drive controllers, an IDE controller, a SCSI controller, virtualized network adapters, all those things. Well, we also create a virtual hard disk, a VHD, and it's a specialized package that creates a file on disk, on physical disk, and to the appearance of the virtual machine, it's a physical hard disk. We can do this when we create a virtual machine. However, we can also do this ahead of time, and depending on the type of disk configuration that we're going to create, we might have to. Understand that with our Generation 1 and Generation 2, we have two different types of controllers for our hard drives, IDE and SCSI. Let's take a look at a side-by-side comparison of those two. So here on the left-hand side, you can see a Generation 1 settings, and on the left side, on the right side, you can see Generation 2 settings. As we talked about in our previous lesson, Generation 1 emulates BIOS firmware. Generation 2 emulates a UEFI firmware. Memory is handled the same. The virtual processors are handled the same. However, in Gen 1, when we configure a hard drive or a DVD, it's attached to an IDE controller. However, just like your old school PCs, you could install an add-on SCSI controller to be able to daisy chain additional drives. And that's there as well, as you can see right in the very middle of that left column, SCSI controller. By default, nothing gets created there. You can add additional SCSI controllers. We can add both network adapters and legacy network adapters. We could attach a COM1 or COM2 port to this as well as a virtual floppy disk file. There's a lot of legacy controllers and interfaces for backwards compatibility to older systems. Remember that if you want to install a 32-bit operating system, it has to be a Generation 1. On the right-hand side with our Generation 2, where we're using the UEFI firmware that's virtualized and a secure boot, by default, we've got a SCSI controller, and we can hook do you remember from your reading how many devices you can hook up to a SCSI controller? What was it, 127? So we don't need those IDE controllers. They're slower anyhow. Also, in Generation 2, we have a virtualized DVD drive. If you need to be able to install from a DVD or an actual DVD, you're going to have to use a Generation 1 VM. In Generation 2, that DVD is simply a virtual device, and it mounts an ISO file. In our network adapters, in Generation 2, we no longer have access to that legacy network adapter. We don't need it. That's the basic difference between those two sets of settings. But you can see where your hard drives and DVDs get connected, how it's different one to the other. Now, when we create our virtual hard disks, understand that if we use the VHD file format, it's limited to 2 terabytes. Now, that may seem very large. However, in an enterprise data center, that may not be. The VHDX format supports disks up to 64 terabytes. It's got larger block sizes, and it's got protection against data corruption if there's a power failure. Understand though that when you create that VHDX, you can't do that in operating systems that are older than Windows 8. We're talking about the system that's going to be hosting the virtualization. So Windows 8 or Windows Server 2012. Before that, VHDX did not exist. If you were going to create a virtual hard disk on a Windows Server 2008 R2 server, you would have to do a VHD. Now, when we create these virtual hard disks, we've got 3 different options. And let's bring that up on our screen and visualize that. We can go to New Hard Disk. When we go into here, you'll notice that there's 3 different file types that they indicate, or types of disks. I mean, we're creating a file, yes, but to our virtual machine it appears as a disk. We could do a VHD if we wanted to. VHDX is typically what we will always do. A fixed size is just what it says. If we create a virtual hard disk of 100 gigabytes, it will grab 100 gigabytes away from your physical storage. Now, the advantage is, because you're assigning that disk space up front, you know that you're not going to overcommit to other virtual hard disks when you're creating them. In other words, with dynamically expanding, we looked at that. When you first create that virtual dynamically expanding disk, it's only a 4 megabyte file. Well, if you're doing this out of storage that only, let's say, has 1,000 gigabytes, it's a 1 terabyte drive, and you start creating 127 gig drives, and you create 1, 5, 10, 20 of these 127 gigabyte virtual hard disks that are dynamically expanding. When they start off, they've taken no room whatsoever. However, as those servers grow and grow and grow and grow, what's 127 times 20? You've just allocated the ability to commit 2.5 times your actual storage. But this is actually a benefit as long as you don't actually consume all that space. Now, the disadvantage of using a fixed storage is if you need to be able to create 127 gigabyte drives, you have to have that 2.5 terabytes of actual storage because you're going to physically allocate it all. And if you never use half of it, you've wasted a lot of space. So that is where dynamic virtual disks do have their benefit. There's no wasted space. You're only using that physical storage that you actually are consuming in those virtual hard disks. But as we saw in our example, as those disks grow and grow and grow, theoretically you could run out of disk storage space on the physical media. And what would happen? Well, what happens if you run out of disk space on your hard disk and your operating system? It stops running, right? So one of the other disadvantages is that you need to manage and monitor your storage utilization a lot more carefully. Now, the third option we see on our screen is differencing. Differencing is what we call a parent-child relationship. What you would do is you would create, remember we talked about imaging and I kept referring to making a golden image that had all your applications or all your settings and everything done, and then you would seal that image? Well, that's what you do with a parent-child. You create a golden image that you want to use as a reference. And in fact, I'm going to show that to you right here. If we come over here, and if you look, for example, on my DC, and I go into settings, on my domain controller, here's my hard drive. If I inspect that hard drive, it says that that LUN-DC1 domain controller is only 19 gigabytes in size. Now, is that reasonable for a server operating system? Well, probably not. You'll notice that this is a differencing disk. Let's look at the parent right here. See, Win 2016 parent. I created this as a reference disk. Let's inspect the parent. The parent disk is only 10 gigabytes. So the actual operation for the LUN-DC1 is a 10 gigabyte parent disk and 19 gigabytes of difference. Thus the word differencing virtual hard disk. This is that configured Windows operating system with no roles configured. This is simply setup. And then anything that's different about that setup, what makes that Windows server unique, that's what gets written to the differencing virtual hard disk. Let's take a look at our storage. If I bring this over here, here is our Hyper-V folder with our virtual hard disks. There's that Win 2016 parent. Now, notice the hard disk right above it. There's the Win 2016 core server that we created with its own hard drive. It's just as big. What about server 4? Well, 8. Once you configure a standalone server, it will grow and grow and grow. So, for example, this server setup that I created, now it's got a checkpoint, but as you can see, it's actually almost 23 gigabytes in size. Let's see if we have any others here. That's Kali. Here is that DC1. Here we can see a change client. This is a Windows 10 machine, and it's over 21 gigabytes in size. What about server 4? Let's see, that was 8.5. Server 3 is only 4.8, almost 5 gigabytes. So let's say the typical server with its configured roles is probably going to run somewhere between 20 and 30 gigabytes in size if it's got its own standard disk. When I say standard, I'm talking about either dynamically expanding or fixed size. By using that differencing disk, this parent disk points to server 4, server 3, server 2, server 1, site 2, site 1, DC. Now, for example, these are configured servers. This site 1, site 2. These are fully configured Windows servers, but look at the size. Less than 4 gigabytes each. So if we take that size and add it to the parent disk, you would get your configured size. So instead of being a 20 to 30 gigabyte drive, we have a 14 or 15 gigabyte drive. What it does is it saves you storage space. If we look here, a differencing virtual disk. It's associated with another virtual hard disk in a parent-child relationship. Thus, the parent and then all the children that are associated with it, where the difference is written to. You start with that parent disk, and you create a differencing disk that points to the parent disk. As changes are made, for example, let's say we install a role. The changes are written to the differencing disk, not the parent. The parent continues to remain unchanged. The parent will not grow in size. Where the changes take place are in the differencing disk. In fact, when you use a differencing disk, you do not need to specify the size of the disk. It simply grows to the size of the disk that's associated with the parent. So for example, when I created that Win 2016 parent, I said you're going to be a 127 gig drive, and it was dynamically expanding. And then I factory sealed it using sysprep, which strips the SID, but it strips that unique ID away from it. And then when we create the differencing disk and point it to the parent, when we start that operating system, it creates a new SID. So let's take a look at this. How do we do that? Now we've got some instructions here, but we've done dynamically expanding disk many times. Doing a fixed size disk would be the same as dynamically expanding, except we're going to allocate the storage immediately. Let's take a look at how we do that differencing disk. You have to create the differencing disk before you create the virtual machine. If I click next and I say this is going to be my test differencing disk, just so it's a name that we can recognize. We're going to click next. It says specify the virtual hard disk that you want to use as the parent. So now we need to point to that parent disk. We select it. We click open. We click next. It says it's going to be a VHDX. It's a differencing disk. Here's our name, where it's going to be stored, and who is the parent. We click finish. Now we're going to go back to Hyper-V and I'm going to create a new machine. I'm going to go virtual machine and we're going to call it, let's call it differencing test. Yeah, helps if I spell that correctly. Differencing test. We're going to click next. We're going to make it Gen 2. Next. We'll leave the memory alone and let it just use those defaults. Let's go ahead and we're going to click connect it to our external switch. Now, if we do this, we will create a new virtual disk. We want to use an existing. We're going to browse and let's see, where is that hard drive? There, our test differencing disk. Just like any other disk, it starts out with 4 megabytes of size. We're going to click open. We've connected to a disk that we previously created. This is how you do it if you want to use a differencing disk. We do next and finish. Let's go ahead and start that. We're going to go into it. Now, instead of running Windows Setup, it's going to immediately start configuring itself, because we're pointing to a disk that already has Windows configured. It was already installed. Look at this. It didn't ask us any questions. It was immediately setting up services and getting ready for us to run Windows. It's a much faster way to implement your operating systems, as well as keeping those files smaller. So it's almost ready to run already. No setup, no questions. Let's see what else we get. It didn't ask us how we want to format our drive, any of that. It asks us, hey, what language do you want to use? Where are you located? We're going to accept the user agreement. We're going to apply a password. And just that quickly, we have an operational server. How long did that take us? Let's see how long this VM's been running. 39 seconds now, 40 seconds. In less than a minute, we have an operational server. How cool is that? That's the power of using a differencing disk. Here's those settings that we saw. We can create a virtual hard disk from within our VMs. And we've done this already, right? Let's go in here. Let's go into our settings. And we can say, we can click on the SCSI controller and we can say, hey, let's add a new hard drive. And right here we say New, and we go through our wizard. We could create a differencing disk this way, or we could browse to one that's already created, just like that. We can do this using PowerShell. We can create VMs using PowerShell. We can create disks using PowerShell. Right here's your command, new-VHD. You tell it where you want to store it. Is it going to be a VHD or a VHDX? How are you going to configure it? Is it going to be fixed, dynamic, or differencing? What size would you like it to be? And you have to do it in bytes. You can specify a block size, the logical sector size, or if you're going to do a differencing disk, then you give the path to the parent. And you create the disk just like that. You remember, it's only making a 4 megabyte file initially. It can be as simple as this command line right here. New-VHD-path, the path to the file where you want it created, -fixed, size in bytes, 4,000 gigabytes. And you're done. Oh, and they also added dash logical sector size bytes. Remember, this is all one line. This is not two lines that are being entered. If you were to do this, you would get an error message when you type in this second line. This is all one line of text. That's an error on the part of the authors. This should be, after 400 GB, it should be a space and then dash logical sector size bytes space 4096. Remember that. If you see that in your worksheets, it's the same thing. It's all one line for your command. And we just looked at adding the virtual disks. If it's a Gen 1, we could add it to our IDE controller 1 or controller 0. How many drives can you attach to an IDE controller? Only 2. IDE controller 0 could have 2 drives attached to it. IDE controller 1 could have 2 drives attached to it. Your SCSI controller can have up to 127. That's why it's so much better to use the Gen 2. You don't even have to worry about those IDE controllers. However, if you need to do legacy, if you got an older system you need to set up, you may have to do those IDE controllers. We talked about the differencing disks. It allows us to preserve our virtual disk image file in its original state. And then we mount an OS and we make modifications. And let's take a look now that we've done that. I'm going to go ahead and bring up our folder again. Hyper-V virtual hard disks. You'll notice that our Win parent, our Win 2016 parent, is still the same size. Here's our test server. Right now, we haven't installed any roles, we haven't done anything like that to it, but it's less than 2 gigabytes in size. That's the power of using a differencing disk. Now, you can clone using a differencing disk, right? So what you do, this is exactly what I did. I created a dynamically expanding disk attached to a virtual machine. I installed my Windows Server operating system. I probably changed like the Internet Explorer enhanced configuration, set the time zone, make sure the time was correct, did some basic things to it. I didn't change the name, I didn't set any static IP addresses, anything like that. Just some minor things that I wanted all my disks that I configured to be the same. Or rather, all the new servers that I was going to point to that parent to have those same settings. For example, I probably ran the sconfig utility and told it not to run Windows Update, because that way I wouldn't have to worry about every time I turned a server on it wanting to download updates from Microsoft. and creating a lot of bandwidth utilization on my network. So you install and configure the baseline VM. That's step number one. Then we generalize it. What we do is we run the sysprep utility, and we say we want to generalize it and we want to shut it down. And what that does is it takes away that unique security ID, the SID. And so that every time you point a new differencing disk to this and start up that new operating system, it gets a new SID. So I could create 1,000 new servers that all point to that one parent disk, and every one of them is unique. And those 1,000 hard drives, those 1,000 differencing disks that are associated with those 1,000 servers only contain the changes. And they could be as little as 2 gigabytes instead of 20 or 30 or maybe more. Now, obviously, as you use the servers, they grow in size. We saw that. But still less than what you would use. You can save size. So that creates that parent disk. The next thing you would do, and I don't think they don't state it here, but what I would recommend is then you go into that virtual hard disk. Now let's see if I did this. Going back over to our virtual hard disk. Let's right click on the parent and take a look at properties. Yeah, see, I put a check mark on read only. That way I can't start it up and make changes to it because I don't want changes made to that. It helps to keep you from inadvertently connecting that to something and then messing up your installations that all these other ones are associated with. So that creates that parent disk. You generalize it and you shut it down. You make it read only. Then when we create that differencing disk, we point to the parent. And then we can create our new VM, and it points to the parent and it creates a clone disk. It's just that simple. We looked at those settings for creating that differencing disk. We just did it. It's always better to do it than just look and read, right? What's a pass-through disk? A pass-through disk, it's a type of virtual disk that points not to an area of space on a disk, but to the physical disk drive itself that's installed on the host computer. Now, after you add a hard drive to any of the controllers in a VM, then you can select a physical hard disk as opposed to a virtual one. However, that physical disk needs to be offline for you to do this. So before you can do that, you need to connect the hard drive to the host computer and start the server. That VM, to be able to use it as a pass-through disk, it has to have exclusive access to the disk. That's why you have to make sure it's offline to the physical computer in Windows. So what you would do is you would go into disk management, and I'm not going to do this because we would have some bad things happen. I would take this offline. Then I could connect that to my VM. And here are those steps to do that. Now, what about editing virtual disks? You can resize them, you can convert them. But what happens if you start to run out of disk space? What if you need to expand that disk? A physical disk, if you've got a 1 terabyte disk and you're running out of space, what do you have to do? You have to go out and buy a new drive and move everything over to it and convert it, and that's a lot of work, right? But you can just expand a virtual disk. Let's take a look. If I go into one of my servers that's not running, so let's say server 3, I go into settings. I select that hard drive and I click on edit. It says, hey, where's it located? Well, it's already selected, right? Do I want to compact it? This compacts the file size. The storage capacity remains the same, but what it does is it compacts that storage in the file. We could convert it, and what that does is it converts a hard disk by copying the contents to a new virtual hard disk. We can use, and when we do that, we can use a different type and format. Let's click next. See, we could select VHD or VHDX. It's already a VHDX, and I don't think I want to do that. We could expand it. We could click next and say, what is our new size going to be? You know what? We want it to be 250 gig. We can do it up to 64 terabytes. Remember, this is generation 2. It's a VHDX. If we go previous, we could merge. Now, be very careful if you do this. Look at what the description says. This option merges the changes stored in a differencing disk into the parent disk or another disk. Now, this wouldn't work because I've got my parent set as read-only. That's another reason why you want to set that parent disk as read-only. But what would happen if you merge these changes? Let's say this was an operational server and you were able to merge those changes back into your parent disk. Well, what happens to all your other differencing disks that are pointing to that parent? They expect that parent to be of a specific configuration. You're going to have problems. If you're going to do that, I would recommend you only have one differencing disk pointing to one parent. But that's what we can do. We can compact, we can convert, we can expand. Now there are other options to shrink, and it reduces by deleting empty storage space. Now remember, the shrink option doesn't appear unless there's free space in the file that the wizard can delete. So if it's not there, it's not even an option. We talked about the merge. Merge is only available if you choose a differencing disk. So you won't even, if you have a dynamic disk, you won't even see the merge option. Now, you can only resize a virtual hard disk if it's in VHDX format. You can only resize it if it's connected to a virtual SCSI controller. So if you've got a Gen 1 machine that's connected to that virtual IDE controller, not an option to resize. And you can only resize a shared virtual disk if it's running Windows Server 2016. And there we saw those edit options as we did that. You can do this through PowerShell as well. Virtually everything you do in the GUI, you can do through PowerShell in the command line. Now, you'll notice that up here we talked about a shared virtual disk. What is that? Well, beginning with Server 2012 R2, you could share a virtual hard disk between multiple virtual computers. So if you wanted to configure a failover cluster, this would be convenient. So it needs to be a VHDX, and it's got to be connected to a SCSI controller, and then you could do that. Now you can store the shared VHDX file only on a failover cluster via the cluster shared volume or the scale out file server. You'll look at those later on in your course. Don't worry about what that is for now. We'll come back to that much later. But those are the only two ways that you can store that shared file. What about quality of service in regards to storage? Well, look at the description. Because it's common for there to be more than one virtual hard disk hosted by a single physical hard disk. Remember, you're putting all these hard disks in one place. They're virtual files. All those virtual disks that we looked at were all stored in the same disk, same physical disk. It is possible that one of your disks could monopolize the I/O capacity of the physical disk. In other words, that would cause all your other virtual disks to slow down. So to help alleviate and prevent this, you can enable the quality of service for a given virtual disk. It helps to ensure the high quality performance for critical applications. So for example, if you were running a virtual machine that had the SQL Server installed on it, you may want to enable quality of service to make sure that you can specify a level of performance for it and any other servers that you deem necessary. Now, checkpoints. What's a checkpoint? Think of it as a photograph. It's a captured image of the state, the data, and the hardware configuration of a VM at a particular moment in time. It's like taking a picture of the world. You have the ability to do either production checkpoints or standard checkpoints. Understand that you can have a maximum of 50 of those checkpoints. You can simply right click on a VM and say checkpoint and manually create one. If we made a change and that change called a failure or an error, we could select revert and revert back to the checkpoint that we had previously taken. What's a standard checkpoint? It's the traditional checkpoint, and it's been available for many years. When a checkpoint's created, any changes to the disk are stored in what's called a .avhd file. Now, later on, if you delete that standard checkpoint, those changes get merged back into the previous checkpoint or disk. If you apply a checkpoint, you're reverting to the state of the system when that checkpoint was made. What's production checkpoint? Well, it uses the volume shadow service, VSS, and it can make a better backup, and it's closer to the state of the system when the checkpoint's created. Now, the production checkpoint, that VM has to start from an offline state to restore that checkpoint. Now, shared storage. Where do we get access to our storage? Well, in my case, I'm attaching to a physical disk on my computer. However, in our enterprise, we're probably going to be using shared storage. For example, file servers need to store data files. Mail servers and database servers need to store large databases. So they typically need a lot of hard drives connected directly to the machine, or those servers will connect to shared storage. I mean, if we have to connect 5 drives to a server, that takes a lot of room. It's better to use shared storage. Shared storage devices have many, many hard disks, and they provide huge amounts of space. And we can do that shared storage in one of two ways, through a NAS or through a SAN. A NAS is network attached storage, and it makes its storage available through a file share. It's just like right-clicking a folder and going to Properties and then going to Share and share the folder. Storage area networks, a SAN, it's a storage architecture, and it allows us to attach to storage in the SAN, and as far as our computer, as far as our server is concerned, it appears as an actual drive connected to the server. It looks like it's locally attached even though it's storage on our SAN in our network somewhere. Most of those SANs, we're either going to use Fibre Channel or iSCSI. We talked about this earlier. Fibre Channel needs to be gigabyte or faster. 10 gigabyte per second is even better. iSCSI sends SCSI commands over TCP. It uses TCP port 3260. For that, we can use standard Ethernet cabling and switches to connect our servers to the SAN. Most of the time through a fiber channel, you're going to use fiber optic. You have to have special fiber channel switches and adapters. iSCSI can use your standard Ethernet cabling. That's an advantage. Maybe not quite the performance of fiber channel, but it's a great advantage. What we talked about this before, a LUN, it's a logical unit number, and that points to a portion of one of those SAN's storage subsystem. It can be a disk, it can be part of a disk, it could be an entire disk array, or part of a disk array. When we configure a server to attach to a SAN, you configure the SAN to assign a LUN, a logical unit number, to a specific server. So that LUN allows you, the administrator, to break the SAN, its storage, into manageable pieces. If the LUN's not mapped to a specific server, that server can't see or access the LUN. Make sure you go through and you understand all the different ways to plan and implement fiber channel. This goes back to what I've been saying in many, many lessons. It all goes to planning. Plan it I don't care how many times you go through your planning, implement it once. As we talked about, most all times fiber channel uses fiber optic, right? It could use DB9 high speed serial data. Most of the time you're going to use fiber optic, and it could be 62.5 or 50 micrometer micron multi-mode. It could be single mode, using those LC or SC connectors you learned about earlier in your course. And you can use a couple different types of topologies. Thought you were done with Network Plus, right? Well, here's some of the new topologies that you use with fiber channel. You got FC-P2P. That's fiber channel point to point. You've got FC-AL, which is fiber channel arbitrated loop. You've got FC-SW, which is fiber channel switched fabric. Understand the difference between those three. Point a point to point is only two things, right? One point to another point. That arbitrated loop, you can connect up to 127 devices. It's a loop topology like a token ring network. The switched fabric is what I would say is probably more common in an enterprise. You can connect up to 16 million devices to it. It provides redundant paths between the connected devices. That's why we call it a mesh or a fabric. So everything's connected to everything. If a switch or a connection between switches fails, the data can find an alternate path, kind of like routing, right? So it's very resilient. And as you can see here, until recently, the FC-AL was the most popular. But the FC, that switched fabric, that's become the most popular fiber channel solution. And there's 5 different protocol layers. Just the same way as we've got our layers in the way that our network stack works, right? You got application, presentation, all those different ones. Well, you've got FC 0, 1, 2, 3, and 4. And each layer defines different elements. Physical elements, data link layer, transport mechanism, common services, and FC4 is your upper layer mapping. The most critical layer is FC4. Now we also have what's called a worldwide node name. It's used to uniquely identify a device in a SAN. Every device has its own unique WWNN. It gets burned in. It's like a MAC address in a network adapter. It's burned into the hardware, or it could be assigned through software. Now there's also a WWPN, a worldwide port name. So a unique identifier for each fiber channel port presented to a SAN. They all use 16 hexadecimal characters. 3 of the bytes are used for the vendor ID. So it's similar in the way we arrange a MAC address. Think of that same comparison. Here we can see the steps for implementing that virtual fiber channel adapter. Now, you have to be able to connect something to be able to do that virtual channel. It requires a computer with a fiber channel host bus adapter or a fiber channel over Ethernet converged network adapter. So you have to have a fiber channel adapter in your physical system for you to create a virtual fiber channel, right? So just the same way as when we create a virtual network adapter, it's connecting to a physical adapter in our server. Well, to be able to do virtual fiber channel, it's the same principle. You have to be able to connect to either a host fiber channel host bus adapter or fiber channel over Ethernet network adapter. Make sure you understand all those requirements. In this lesson, we talked about what a specialized VHD format is and how it's a file that's created in a part of our physical disk and to our virtual machine, it appears as a physical hard disk. When we start that virtual machine up with that new virtual disk attached to it, and we install an operating system in that virtual hard disk, we're not affecting the partitioning of the physical disk. We're not rebooting the host machine when that VM reboots. It's just the VM. We talked about a pass-through disk and how it's an actual complete physical disk that we can attach to a VM. But to be able to do that, that disk that's in the physical system needs to be offline. We looked at that in disk management. We talked about checkpoints and the different types of checkpoints. And then finally, we delved into our difference between NASes and SANs and fiber channel, and how if you want to create virtualized fiber channel, you actually need to connect to a fiber channel host bus adapter or over Ethernet network adapter. Because just like creating a virtualized switch, and a virtualized network adapter in our VMs, they connect to a real network adapter. Our virtual fiber channel has to connect to a real fiber channel. Thank you for reviewing 70-740 Lesson 9.